Okay, so we're going to start talking about the 6 trigonometric functions. And in the pre-calculus we talked about a lot of different types of functions. Polynomials, rational functions, exponential functions, logarithmic functions. For this semester we're going to spend our time talking about these 6 trigonometric functions. And probably most of you have heard of the 6 trig functions in either Algebra 1, you touched on them a little bit, or in geometry. And probably the way they were introduced to you is with a right triangle. So that's what I'm going to, that's how I'm going to introduce the 6 trig functions here. And then we're going to look at these functions a little differently with what's called the unit circle. But right now I want to start off with the 6 trig functions looking at a triangle. Now you'll notice first of all that I didn't put a notation that this is a right triangle, so I'll go ahead and put a little indication there that it's a right triangle. Remember that the side immediately opposite the right angle is called the hypotenuse. So C is the hypotenuse. Now, these triangles have, we're going to see, and of course I'm denoting this angle A, this angle B, and this angle C. And notice the side opposite this big C is little c, side opposite big B is little b, and big A, the opposite is little a. But what I want to take note of is this. First of all, we need to familiarize ourselves. Let's just consider this angle A. Now, with respect to this angle A, notice what we have. We have a side opposite angle A, this side right here. So we're going to be talking about, given an angle, we're going to be talking about the side opposite that angle. And we've also got a side that's adjacent to angle A. So this B is adjacent to A, and A is across from big A. Okay? And then, of course, you have the hypotenuse. So for any angle that I talk about on that triangle, we have 3 sides. We have the hypotenuse, which is the same no matter what. We have the side opposite the angle and the side adjacent to it. Does everybody see that? So for example, with B, the side adjacent to B is A, and the side opposite B is little b. Okay? Now, here's what I want to do. I want to define for you these functions. Now, these are just definitions of 6 functions that we're going to be studying. First of all, there's the sine function, which I abbreviate just SIN. That's the standard abbreviation, but it's sine. Okay. Okay. And we talk about sine A. Now this is like, this A is not being multiplied by sine. This is just saying take the sine of A. It's sort of like a radical, where we say take the square root of 4. Well, that's what this is. This is just saying the sine of A. And what it's talking about is a particular ratio. And that ratio is the opposite side over the hypotenuse. So, when you think of sine, you think of whatever angle you're dealing with, it's the ratio, the opposite side over the hypotenuse, like that. Okay? Any questions about that? Now we also have cosine. And I'm putting over here on the left the most common trig functions the ones you're probably most familiar with. Cosine A is like sine A, only it's the adjacent over hypotenuse. So it's the adjacent side over hypotenuse. So in this particular example, that would be B over C. So here we've got sine, here we've got cosine, and now, does anyone remember what the tangent is? Do y'all know these? That's right. Tangent would be the opposite side over the adjacent side. So A over B in this particular case. Okay. Any questions about that? Okay. Now let's look at these other functions. I'm going to go over here and put the cosecant. Now, cosecant. And I'll write these up. I'll write these in just a minute. But this is the abbreviation. I didn't leave myself room to write it here, but I'll list these for you in just a second. So we have the cosecant of A. Now the cosecant of A is going to be the hypotenuse over the opposite. So now we're getting into some territory that might be a little strange to you, because probably you haven't seen much about cosecant. And then, of course, we have secant. And secant is going to be C over B. And then finally, we have cotangent. Cotangent of A is going to be B over A. Okay. Any questions about that? So these are just definitions. So here's what we've got here. Notice what we've got. We've got sine, and I'll spell them out up here. We've got cosine, and we've got tangent. Okay. Now, sine is going to be the opposite over hypotenuse. Okay. Cosine is going to be adjacent over hypotenuse. And tangent is going to be opposite over adjacent. Any questions? Okay, now let's look at cosecant. Cosecant is going to be hypotenuse over opposite. Okay. And then we've got the next one is secant. Which is hypotenuse over adjacent. Okay. And then finally cotangent. And cotangent is going to be adjacent over opposite. Any questions about that? Okay. No questions? Okay. Now, let's look at a particular example of a triangle where we've got, this is a 3, 4, 5 right triangle. We've got the angle theta. And what I want to do is I want to go ahead and write the 6 trig functions for theta. So here I go. I'm going to start off with sine theta. What is sine theta? It's going to be 3 over 5, right? Okay. Now remember, the hypotenuse is always the longest side of a triangle. So this is sine theta is 3 over 5. What about cosine theta? 4 over 5. And what about tangent of theta? Okay, opposite over adjacent, so it would be 3 over 4. Now let me just ask you a question. Will sine ever be greater than 1? It won't be. Well, why not? That's right. The hypotenuse is always the longer side. So with sine, you're always going to be putting a bigger number on the bottom than you do up top. And the same for cosine. Okay? Does that hold for tangent? That's right. It doesn't hold for tangent because tangent, you could have the opposite side bigger than the adjacent side. Okay, now let's look at cosecant. The cosecant of theta. What would be the cosecant?
5/3.
5/3. Okay, good. Now what about the secant of theta? 5/4. And the cotangent?
4/3.
Okay. Now, does anyone see a relationship between sine and cosecant? Yeah, they're reciprocals, right? Reciprocals of each other. Now that's why some of you may have wondered, well, why do I put sine and then cosecant? It seems like secant should go with sine. The reason I did that was because sine and cosecant are reciprocals of each other. Notice also cosine and secant are reciprocals of each other. And tangent and cotangent, those are both reciprocals of each other. So that's why I put them like that. So really, here's what we have. We have sine, cosine, tangent, and then they're reciprocals. You can think of it that way. So if you just remember sine, cosine, and tangent, remember those three, and then remember what they're reciprocals. The reciprocal of sine is cosecant. Reciprocal of cosine is secant, and tangent, cotangent. Any questions about that? Yes, sir.
Is cosecant the same as like the sine -1?
No. The question was, is that what you were asking, Chad? No. What we're going to do is, that's a good question though, but we're going to study later on what the inverse, this means inverse of sine. And later on we're going to study what that means. Now this is true. If you look at it this way, if you were to say sine theta to the -1 like that, then that is true. That is true then. Okay. Any other questions? Okay. Now, so let's look at another example then. Let's look at this one. Now this, of course, is there anybody that remembers, there's a special name for this, huh? It is a 90-degree, a right triangle, a 30, 60, 90. That's right. Is that what you said? Okay. Okay, so this is a 30, 60, 90 triangle. Now this is a triangle that we're going to be working with a lot, especially a little later when we start to talk about the unit circle and building the unit circle. But what do we know about a 30, 60, 90 triangle? Let me just start off with this. What do we know about the side opposite the 30 degree in relation to the hypotenuse? That's right, it's half of it. That's right. We know that the side opposite the hypotenuse in a right triangle, the side opposite the 30-degree angle in a right triangle is half the hypotenuse. Now remember that sides opposite larger angles are longer, right? So for example, we know that this 1/2 over here is opposite 30. Well, we know that the side opposite the 60 is going to be bigger. Well, what is the side opposite the 60? It's 1/2 the hypotenuse times the square root of 3. In other words, it's a little bigger. It's 1/2 the hypotenuse times the square root of 3. Or you could just write the square root of 3 over 2. Does everybody see that? Any questions? Now that's just something going back and reviewing, something you probably hadn't looked at since geometry. So remember, the side opposite the 30-degree angle is 1/2 the hypotenuse. The side opposite the 60-degree angle is the same, half the hypotenuse, only times the square root of 3. Okay, any questions? Okay, well, let's look here then at sine of 30. What is the actual value of sine of 30 degrees? I guess I better put the little symbol here. Okay, what is the sine of 30 degrees?
1/2 over 1.
That 1/2 over 1, that's right. Would you write it that way? Yeah, just 1/2. In other words, you don't have to put it over 1, do you? Because, I mean, you could write every number that way. 6 over 1, 7 over 1, but we don't do that. Or you could write 7 times 1. We just generally leave that off. Now, what about the cosine of 30 degrees? Yeah, that's right. Right. The square root of 3 over 2. Now, these values you're going to be seeing over and over again. The values that come from this special right triangle, 30, 69, you're going to be seeing repeatedly. So, you should get accustomed to them. The sine of 30 degrees, the cosine of 30 degrees. What about the tangent? This one's a little bit less straightforward, but what would it be? Square root of 3 over 2. Oh, look at that fraction. Now, how would you deal with that fraction?
Make slants. Instead of like going across, make slants.
Okay. Okay, I think what you're saying... What we really have is, I mean, this is another way to look at it, right? 1/2 divided by the square root of 3 over 2. Well, remember, when we're working with fractions, we invert and multiply. So this would be 1/2 times 2 over the square root of 3, right? Is that correct? And the 2's cancel, and you just get 1 over the square root of 3. Okay? So that is what this is. It's 1 over the square root of 3. Now, a lot of times you won't see it written that way. 1 over the square root of 3. Because on many occasions we like to rationalize the denominator. If we have an irrational number in the denominator, we like to rationalize it. Does anyone remember how we do that? How we get that square root of 3 out of there? That's right. Multiply the top and the bottom by the square root of 3, and that will fix the situation that we had here. Because look, up top you just get the square root of 3. And on the bottom you get the square root of 3 times square root of 3 is just 3. So there's what we have for tangent. Any questions about that? So these are kind of fun, aren't they? Trig. Trig's a fun topic. Okay, now let's go ahead and now look, we've got those 3 functions. What function would you write down next? Okay, let's look at that. Cosecant of 30 degrees. What does cosecant of 30 degrees equal? That's right, just 2. You just flip this one, right? We're finished with this triangle. We can just look over here. Now, what about secant? Okay, secant. Let me get my pen back. Okay, secant is 2 over the square root of 3, right? Now, if we wanted to rationalize that denominator, what would we get? We multiply the top and the bottom by the square root of 3. So we get 2 square roots of 3 up top and on the bottom 3, right? So if we wanted to rationalize the denominator, that's what we would do. Now, let's go ahead and do the cotangent now. Cotangent of 30 degrees. That's right, 3 over the square root of 3. But then we might want to rationalize the denominator. But look, what if we just go back and say, well, before we rationalize the denominator, we had 1 over the square root of 3. Why don't we just flip that and just call it the square root of 3?
Is that because like when you have 3 square root 3 over 3, the 2 3's can cancel out?
That's right. That's right. Okay, does everybody see what we did there now? Notice, once we got the sine, cosine, and tangent, it just meant we flip everything else. Okay. Any questions about that? Okay, now, let's look at the 60 degree. So we want to find the sine, cosine, tangent of 60. So what would that be? I guess I need to make myself some more room. Or actually, I think what I'll do, I'll just copy this, see if I can copy it. Okay, so there's our triangle. Okay, so let's look here at this. We've got sine of 60 degrees. What is the sine of 60? It's opposite over hypotenuse, so it's going to be square root of 3 over 2, right? Does everybody see that? Any questions? Now, while we're there, why don't we just go ahead and get this cosecant of 60? What is the cosecant of 60? 2 over the square root of 3. Or we could write 2 square roots of 3 over 3 if we want to rationalize the denominator. Either way. Okay. So see, once you get the trig function, then just reciprocate and you'll have the, it's reciprocal. So let's look at cosine of 60. What would that be? Okay, 1/2. And then what's next over here? Secant. That's right. Secant of 60. And what would that be? 2. That's right. Okay, now one more is the two more, tangent and cotangent. What is tangent? Right. That's right, it does. It simplifies the square root of 3. One way you can do that is just say, well, I multiplied the top and the bottom by 2. And if you do that, notice what you get. 2 and 2. Okay, now let's go ahead and do the cotangent. Cotangent of 60. Okay, so it's going to be 1 over the square root of 3, which is the square root of 3 over 3. Okay, any questions about that? So really what I'm doing here is we're just looking at some examples of these trig functions, how to find the trig functions of when it's showing you how they work. But I'm kind of doing double duty here because this special right triangle that we're working with, 30, 60, 90, is something we're going to see a lot. And the fact is, you're going to need to know what sine of 60 degrees is. I mean, it's square root of 3 over 2. That's something you're going to need to know. And it's going to be helpful when we look at the unit circle if you know what that is. We'll explore this again, but these are called special triangle function values. Okay. Any questions? Now let's look at this one. This is another special right triangle. Anybody know the name of it? Yeah, 45, 45, 90. Those are creative names. Now, how can we figure out what this side over here is? We know the hypotenuse is 1. And let's suppose we just forget. I don't know. I know these sides are equal. I know they're both x units long because they're both opposite the same degree angle. They're both opposite 45-degree angles. So how can I figure out what the length of that side is? Anybody know? Well, is there any technique that you've ever learned where if you have a right triangle you can find a missing side? What is it? Yeah, we know that x squared plus x squared equals 1 squared, right? Because on Pythagorean theorem, you have a squared plus b squared equals c squared. So the sum of the squares of the two other sides are equal to the square of the hypotenuse, right? So that's what we have here. So look at this. we have 2 of these x squareds, which equals 1, right? Now I'm going to solve this equation for x. Dividing by 2, I get x squared equals 1 over 2. Now I'm going to square root it. And this is what we get. Now, I put plus or minus there, but you realize that since we're dealing with a length here, we're not going to, I'm going to just throw out the negative. So really, x is 1 over the square root of 2. Now, is there any way we can rewrite that to rationalize the denominator? Because that's the way you see it a lot of times. That's right, square root of 2 over 2. So it looks like that's what these sides are. They're both square root of 2 over 2. Any questions? Everybody see what we did? Now, what does that tell us right away about tangent and cotangent? What is tangent equal to? Okay, so if we have the tangent of 45, what is tangent equal to? This is something, 1, that's right. Since these sides are the same, square root of 2 over 2, square root of 2 over 2, tangent of 45 must be 1. The same for cotangent. They must be 1. Now, so let's look at the other functions. Let's look at sine. What about the sine of 45 degrees? What is that equal to? Yeah, square root of 2 over 2. And what about its reciprocal? Okay. It'd be 2 over the square root of 2, right? Is there any other way we could write that? Yeah. Yeah, that'd just be square root 2, wouldn't it? I'm running out of board space, so I didn't show you the work. What we did here was just multiply the top and the bottom by the square root of 2. That left a 2 on the bottom, which canceled out with the top. So you just have the square root of 2. And notice you could have looked back to the original x value, which was 1 over the square root of 2, right? And then reciprocate that, it's just the square root of 2. Everybody see that? Okay, what about this? What about cosine of 45? What about this one? What is the cosine? Yeah, square root of 2 over 2. And likewise, the secant, by the same old little game we played earlier, must be the square root of 2. See, these 45-degree angles are kind of easy to work with. Okay, what about tangent? 1 and cotangent. One, right? Any questions about this?